Kia ora and hello. My name is Jose Borrero, and I'm a tsunami scientist and researcher, and I've been working in tsunami research and consulting for more than 25 years. My career started in California at USC in Los Angeles, where I did my Ph.D. work doing post-tsunami field surveys, developing numerical models, and producing California's first set of tsunami inundation and evacuation maps. Just over 15 years ago, I left California and moved to Aotearoa, also known as New Zealand, where I now work as a partner in a small oceanographic and environmental science consulting company. Our company is called eCoast, ECOAST, and you can find us on the internet at ecoast.co.nz. Tsunamis are still a big part of my world, and I've spent a lot of time working on tsunami hazards and research here in Aotearoa and the wider South Pacific. I've done a bit of everything down here, from developing inundation and evacuation maps to post-event surveys from local events like the 2014 Kaikoura earthquake and tsunami, and lately I've been focusing on tsunami hazards at ports and other maritime facilities. The March 11th Tohoku, Japan earthquake and tsunami will be remembered for so many reasons. First off, it was a huge earthquake, and the resulting tsunami killed more than 15,000 people. Also, we had the meltdown of the Fukushima nuclear power plant, which is directly attributed to the tsunami, and specifically the underappreciation of the tsunami potential from the subduction zone offshore. For me, I remember that the earthquake occurred on a Friday afternoon. I'd finished work for the day and I had an after-work beer with the staff. It was in the 10 minutes that it takes me to drive home from the office that the earthquake happened. When I left the office that afternoon, it was a normal late summer evening, but by the time I got home, it was total hysteria in the tsunami and disaster world. I spent the rest of the night buzzing on adrenaline and caffeine as I did modeling work for the New Zealand Civil Defence to give them an idea of what we might expect from the waves when they finally got to New Zealand some 12 hours later. I was up all night, but in the process, I was able to provide some useful and accurate model guidance that, thanks primarily to the Commit Tsunami modeling tool developed by the Tsunami Group at NOAA's Pacific Marine Environmental Laboratory in Seattle. That software really showed its strength that night, and ever since then I've been using it as my primary tsunami modeling tool. The lessons learned from the great tsunamis of the early 2000s, Sumatra 2004, Chile 2010, and Japan 2011, have been a huge part of the progress and development of tsunami science worldwide, specifically down here in Aotearoa. The 2004 and 2011 events made us realize that any subduction zone can pop off a magnitude 9 earthquake. Before those events, it was often assumed that the possibility of such huge earthquakes could be discounted for certain subduction zones, but not anymore. Offshore of Aotearoa's east coast, we have a subduction zone that runs from the North Island all the way up to Samoa. This feature is called the Hikurangi Margin in the south, adjacent to New Zealand, and the Tonga-Kermadec Trench as it runs north to Samoa. This is the plate boundary between the Pacific and Australasian tectonic plates, and the scary thing is, it hasn't had any huge earthquakes that we know about. There have been a few decent events like the September 2009 earthquake and tsunami up in the north offshore of Samoa. Then there was the 2014 quake in Kaikoura, which is at the southern end of that fault. And we've had a couple of 8s in the middle, like the one we had last Friday, the 5th of March, 2021. All of these events produced tsunamis and were significant in their own way, but still, we have no solid evidence of very large, high-magnitude 8 or 9 earthquakes along this margin. This is similar to what happened in Japan. They also hadn't experienced such large earthquakes on that subduction zone, nor in Sumatra in 2004. So, the million-dollar question is, can it happen here? Of course, after Sumatra and Japan, we would be foolish to think it couldn't. So taking a cue from the Japan event, we've been using Tohoku-like earthquake scenarios to initialize our tsunami hydrodynamic models for the purposes of producing worst-case type evacuation maps and community education products. In many ways, the east coast of New Zealand is like the northwest coast of North America. Both areas have subduction zones offshore that have never produced huge earthquakes in historical times. North America has a bit more concrete proof of past large earthquakes from the tsunami deposits and geological signature along the Oregon and Washington coasts, but in New Zealand we don't have much other than some archaeological evidence and vague oral legends from the Maori, the indigenous people of Aotearoa. One of our most vulnerable areas is the East Cape. And one place in particular, known as Poverty Bay, is geographically similar to Sendai, Japan, and the Sendai Plains. At the northern end of Poverty Bay is the city of Gisborne, with its port that sits at the mouth of a river, and behind it is a wide, low-lying coastal plain. Incidentally, my partner's family is from Gisborne, and her mom lives on one of the most vulnerable parts of the coastline in that area. Our models of tsunami inundation in Gisborne give results that are frighteningly similar to what was seen in Japan. By that, I mean we predict up to 5 kilometers of inland inundation over the Poverty Bay Flats and tsunami run-up heights well in excess of 20 or 40 meters on the steeper coastlines to the north and south. The fact that I have family in the inundation zone just makes it all the more important to me. Another area of learning that was important from the Tohoku event was the potential impact of Farfield Tsunami on ports and maritime activities. Here in New Zealand, the tsunami first arrived around 7 a.m. on Saturday morning, 12 hours after the earthquake in Japan. It was a beautiful, sunny and warm early autumn day, and there were a lot of activities planned in and around the water. On the northeast coast of the North Island is a town called Whitianga, where they had a boat race and a fishing competition planned for that day. Because the arrival time of the tsunami was at like 7 or 8 in the morning, most people thought they could just wait until 8:30 and then, go on about their regular day out on the water. But no, between noon and 2 p.m., the largest tsunami surges began arriving, and this caught a lot of boating people off guard. The surges lasted for several hours and nearly caused a bunch of collisions as people tried to get their boats back in to the marina after a long day on the water. It was just luck that no one was hurt or that any boats were damaged in the ensuing chaos. There were also some really strong currents observed at several harbors along the coast. It was these observations, plus seeing the damage firsthand in Crescent City, California, that spurred me into focusing on aspects related to maritime hazards from tsunami, especially for cases where the primary effect is strong currents as opposed to on-land inundation. This has led to a couple of projects here in Aotearoa where we've developed tools for decision-making and emergency response specifically targeted at the maritime community. I'm happy to say that these tools are in place and were used twice in recent weeks here in New Zealand. 3 weeks ago on February 12th, when there was a 7.8 earthquake south of Vanuatu, and just last week with the 8.1 along the Tonga-Kermadec Trench. Both times the harbor masters used these products that we produced to aid with their decision making and their action plans. So, in summary, we really need to learn and remember from these events. The period from 2004 to 2011 will be remembered for its 3 large tsunamis, but these might not happen again for quite a while. It could be like the 40-year gap between the Chile and Alaska tsunamis of 1960 and 64 and the next really big one that occurred in Sumatra in 2004. Or it could be a lot longer. We really don't know. What is important is that we remember and pass this knowledge on so that people in the future don't get caught out unexpectedly. Thanks for watching, and please stay tsunami safe.